Good morning, everyone. This is Dynamics of Mechanical System, practical number 1. The practical is static and dynamic balancing of rotating mass system. And in this practical, we are going to demonstrate the static and dynamic balancing of the 2 and 4 rotating masses. Okay, then in the setup there are mass blocks, and first we are going to use 2 mass blocks and check whether it is dynamic balance or static balance. Right, let's see 2 mass blocks. Right, in this setup you can see in the shaft there are 2 mass blocks are fixed, and the mass blocks are in 180 degree angle difference. So if the system is balanced statically, then we can say that center of gravity of system, right, in the axis of rotation, right. Then you can see here in this picture, if that center of gravity is in the axis of rotation, that means that the R2 W2 is equal to R1 W1, right. And if it is statically balanced, that means the shaft is, if we rotate in any angle, it will remain in the same position, right. Let's see about the dynamic balance. To check the dynamic balance, you can see when we rotate the shaft that there will be a centrifugal force, right. To understand the dynamic balance, we have to know about the centrifugal force, right. Centrifugal force is noted by this arrows, right, F1 F2, right. It is opposite direction, but the blocks have some distance, no, therefore there will be twisting moment or couple, right. Because of this twisting movement, there will be vibration in this system, right. From the bearings, you can see, or you will feel, right, you can feel the vibration, right. Therefore we say it is not dynamically balanced. Okay, let's move to the practical. First, this is the apparatus for the static and dynamic balancing, right, for this practical. And here above the control panel you can see there's a glass that is for the safety, right. When we remove the glass, you can see inside of that rotating shaft, right, and the motor and the pulleys, right. Motor and the pulley connected by using belt, right. And this is these two are the mass blocks, right. In here linear scale, right, we can fix the mass blocks in required distance, right. And this is circular scale, right, for the angle, right. Because we have to fix the blocks in different angles, no. Therefore in the circular scale we can see there are two different circular scale with this angle, right. Angles 0 to 360, right. Okay, now we will make the two mass system, right, which we discussed previously, right. Same as this two mass blocks are in 180 degree different angle, right? And we will make it and check whether it is statically balanced or imbalance, and also we will check dynamically balance or imbalance, right? Right, this is the simple two mass system, right? The mass blocks are in 180 angle difference, right? And how we can check this statically balance or not, right? For that we have to rotate in some angle and see it is remain in that same position or it will change the position, right? It is remain in that same position, right? Therefore it is statically balanced, right? To check the dynamic balance of this two mass system, we have to rotate it, right? First we have to rotate it and see whether it is vibrating or not, right? If this two mass system is statically balanced, that means there is no couple or twisting movement in there, right? uh, let's see, by rotating this two mass system, see whether it is vibrating or not, right? First we have to fix this pulleys, shaft and the motor by using belt, and then we have to close this glass for the safety, and then we have to press, by pressing the motor switch we can rotate the two mass system, right? This is motor switch, right? When we press it, it will rotate, right? You can see while rotating. From this video you may not be able to feel that vibration, but in this practical, in reality, there will be vibration, right? Because it is not dynamically balanced. That means two masses are in some with some distance, no? Therefore there should be some couple or twisting movement. Okay, now here let's see about the three mass system. In this three mass system, you can see there are three mass blocks, and space between the mass blocks are same, and it is 60 millimeter. Okay, and this three mass system statically balanced because the center of gravity of this system is in the rotation of axis. And when we rotate this three mass system, there will be no thrusting movement or couple, right? Therefore it will not produce any vibration. Okay, this is the experimental system, right? In here you can see that we can, by changing the angle, we can see it will be statically balanced or not. When we turn it some angle, you can see it will remain at that same position. That means it is statically balanced system. And we know it already. It has that center of gravity in that axis of rotation, therefore it is statically balanced. And to check the dynamic balance of the system, we have to rotate it and observe whether it is producing any vibration or not, right? And you can see that while rotating there will be no resultant of centrifugal force, and there will be no twisting movement also, right? And to check the dynamic balance of this three mass system, first we have to connect the shaft pulley and the motor pulley by the belt, and we have to release the clamp so that we can observe whether it is vibrating or not, right, in this system. Then we have to close the safety glass, and we have to start the rotation. In this video you may not be able to feel the vibration, but in reality you can feel the vibration by placing the hand on the apparatus, right? In here there will be no vibration. That means this three mass system dynamically also balanced. All dynamically balanced system are statically also balanced. Okay. And for your lab report submission, there are 5 discussion questions, right? You have to answer for these questions, and you have to write down the introduction for static balance and dynamic balance, right? And if you have any clarification or any questions, you can contact me, right? Thank you.